If you want to check how well you have prepared well in case of inorganic chemistry, this video is for you. If you can solve this question very easily, you have prepared very well in inorganic part. Okay, so without any further delay, let's get started with the first question. Find the number of reactions in the given set of separate experiments which would give you white precipitate. They are asking for white precipitate. Okay, so what are the reactions given over here? All of these are reacting with sodium carbonate. Okay, some of them may give white precipitate, some of them may give precipitate but not in white color, and some of the solutions which will be forming a soluble salt. Okay, let's see one by one. First, sodium carbonate with barium chloride. What that will form? That will form barium carbonate, isn't it? So that will form barium carbonate, which is in white precipitate, right? Okay, with calcium chloride, again that will form a precipitate which is white in color, calcium carbonate. Then ammonium chloride. With ammonium chloride, it will form a soluble salt. This question is basically from first and second group element. Okay, group 1 and group 2 elements, how well it is reacting. And then lead acetate with sodium carbonate. What that will give? That will again give lead carbonate, which is white in color. Then copper chloride, it will form copper carbonate, which is not white, but it forms a precipitate of blue to green color. Okay, then mercury chloride. Mercury chloride will form a precipitate of mercuric oxide, but that is not white in color, that is brownish yellow. In this video, I try to cover all concept of inorganic part which you need for JEE Advanced. Please watch it fully and try to solve it side by side. Okay, strontium chloride, that will give you white precipitate, and mercuric nitrate, that will give you yellow, but the clue point is here is that yellow, but over the time it darkens. Okay, that is the point. Then it's again repeating the calcium chloride. Okay, so how many white precipitate is this forming? 1, 2, 3, and calcium carbonate also 4. So total 4 is our right answer. It is an integer type question. Next one, from a given salt, barium chloride, calcium carbonate, sodium nitrate, potassium sulfate, potassium carbonate, barium sulfate. Among this, which salt will turns red litmus blue, impart lilac color to the Bunsen flame? Both the conditions must be satisfied. Okay, so which must be our right answer? The clue point here is that they are mentioning that is lilac color. Calcium, that will give you brick red color in the Bunsen flame, and barium apple green, right? Sodium golden yellow or yellowish tint, right? Only the potassium salt, here we have potassium nitrate, potassium sulfate and potassium carbonate. Only the potassium salt will give you lilac color. Ma'am, what about the other condition which turns red to blue? These are salts, but how you can find whether it can turn that to red to blue? Red to blue means what? It should be of base, right? So here you can see these two are made up of strong acid and strong base. Okay, potassium hydroxide with HNO3, potassium hydroxide with sulfuric acid. So which is forming a salt. It won't be giving any changes on the litmus paper. This side, potassium carbonate, you can take, that is made up of strong acid, strong base with weak acid. Okay, which can give you the change red litmus to blue. So answer to this question is 1. Okay, then moving on to the next question. These are the type of match the column. I'm not going to give you the options, just to match it. I'm here to teach all those concepts via how it can be asked. So column 1 is given the order and column 2 is for the properties suitable for this order. It can be of more than one, as always asked in JEE Advanced. Okay, so let's analyze one by one. First we have beryllium fluoride, barium fluoride, strontium, calcium, magnesium. here you can see it starts with beryllium fluoride or same overall, but it starts with beryllium, but the changes, there is a change here, right? Magnesium is more, magnesium fluoride is showing more. Magnesium fluoride has the highest lattice energy. It's because of due to the smaller size of magnesium 2 plus and high charge density, isn't it? Then comes calcium fluoride and then strontium, barium and beryllium. So A to P. Then lithium bromide, sodium, potassium, rubidium and cesium. Cesium takes more. Here all are bromide. So we have to look into only for cations. In that case, ionic character makes sense, right? As we move down group 1, the ionic character increases as the alkali metal become more and more electropositive, right? So this can be our answer. So B to yes, fine. Then C. C, here you can see hydroxides are given and beryllium, magnesium, calcium, strontium, barium, which is in an order. So here, which will be suitable for solubility in water and thermal stability also. Why solubility in water? Because as we move down the group, in case of group 2 here, they are mentioned group 2, the solubility of hydroxide generally increases, isn't it? Because of the size and it can, the lattice energy changes, it can easily, the solubility increases. So C takes Q and as well as R, because thermal stability of hydroxides also increases down the group. Then carbonates are given of group 2. Here you can see what we can position it. Lattice energy, it's because of the decreasing lattice energy down the group. So D to P. Then you can take thermal stability also, ionic character also. All these are carbonates. Ionic character increases down the group, right? That is also matching over here. So P, Q, and yes. Okay, so this becomes answer to this question. And the next question is again the master column. You can see the first one is anhydrone, then anhydrite, oxone, gypsum, and gypsum at 200 degrees Celsius. So in this type of master column, if they are giving you the only one is correct to one part of column 1, then you can easily solve, because gypsum and gypsum at 200 and 120 is given over here. As you see, gypsum 200, which belongs to T, right? Then gypsum 120, which will be losing only 1.5 moles of H2O to form P. Then our oxone, which is sodium peroxide with HCl, that will form oxone. Then anhydrite, that is again calcium sulfate, and anhydrone, you can see that is the bleaching agent magnesium chloride, right? So AQ, BT, CR, DP and ET is your answer. Then this type of questions you can expect given the reactions. The reaction of an element A with water produces combustible gas B and an aqueous solution of C. When another substance D reacts with this solution C, also produces the same gas as B. D also produces same gas even on reaction with dilute H2SO4 at room temperature. And the clue point over here is element A imparts golden yellow color to the Bunsen flame. So I already told you golden yellow color is for sodium. We saw lilac color is for potassium, apple green, that is barium, and blue is for copper, and so on, right? So the clue point is always given, sometimes they will give you in colors of the Bunsen flame. So by knowing that, you can emit other two options very easily. Actually, other three options very easily. Only we are left with first one, right? Sodium, H2 and NaOH. Let's check with the reactions as well. So sodium, it's reacting with water to produce the combustible gas B. So let me write the reaction. Sodium with H2O, it is giving NaOH plus H2, isn't it? That is NaOH is C and H2, that is B. Then what we have, when another substance D reacts with the solution C, also produces the same gas. So D, we are taking that as zinc, right? So that will metal with alkali, that will produce H2 gas, that is B, along with that sodium zincate, correct? That is also producing gas B. D produces the same gas, even the reaction with H2SO4 at room temperature. So zinc with H2SO4 also, sodium zincate with H2 that will form. So answer to this question is sodium, H2, NaOH and zinc are A, B, C, D. Then the next question, a reddish brown liquid A on treatment with ozone forms a pale yellow solid B. B on reaction with NaOH forms C and D. Similar products of C and D are obtained when A is treated with hard and concentrated NaOH. Right? B on decomposition forms dark brown liquid. Once again, I am telling you, colors play an important role in these type of questions. Dark brown liquid E. All A2E burns with green edged flame when put on a fire in Bunsen flame. E on reaction with I2 produces X, which forms stable white hygroscopic crystals. Select or correct option about X. Okay. So they have given all these details and asking for X. Okay. So let's check. Let's find out what X is. Okay. The only clue point over here is that dark brown liquid. B on the decomposition gives dark brown liquid. So in your lab also you might have seen bromine is stored in a dark bottles because it can easily get reacted in the surrounding sunlight, light. Okay. So here we have A reddish brown liquid on treatment with ozone forms a pale yellow solid. Okay. So Br2 with ozone, that will form BrO2. The next one, that is B on reaction with NaOH forms C and D. Similar products of NaOH is obtained when A is treated. Okay. So B with NaOH, we got NaBr and NaBrO3, isn't it? The similar products will be obtained when A is treated with NaOH also. So here also we are getting NaBr and NaBrO3. These are C and D. Okay. The next one, that is B on decomposition told, and all A2E burns green edged flame when put on wire. Okay. E on reaction with, which is E, so on decomposition, which will give you bromine, Br2O, bromine oxide. E on reaction with I2 produces X. Okay. E upon decomposition gives Br2O with O2, which is dark brown, and this with I2 gives I2O5, isn't it? With 5Br2. So our main culprit is X over here, that is I2O5. We have to match this PQRS with I2O5. It is highly water soluble. Yes, it is highly water soluble, and it is a gas, and it is an oxidizing agent. Of course, I is in +5 oxidation state, which can go to below that state as well. And it is an anhydride of highest oxy acid of iodine. That is also true. It is used analytically for the detection of estimation of carbon monoxide. I2O5 plays an important role in analytical chemistry. So all 5 are true. All of these is your answer. Okay. Then washing soda reacts with nitrolim to give A and B. To know this question, you must know what is nitrolim is, right? To give A and B, B is the basic flux. A on acidification gives C, that is an extremely poisonous gas. C on acid hydrolysis forms D, which on dehydration forms E. E on reaction with NaOH under high pressure conditions forms sodium salt of D. So the reaction is very simple once you know what is nitrolim is. Okay, we know about washing soda. Sodium carbonate. Sodium carbonate, what is nitrolim? It is calcium cyanide. Okay, then it will give A and B. So calcium carbonate and NaCN. You can see cyanide, which is C, and B is the base. Sorry. So here you can see B is the base. Okay, and A is sodium cyanide. That is also poisonous only, but extremely poisonous on acidification, which will give HCN and sodium. So this is our C, isn't it? So C on hydrolysis to form cyanide upon hydrolysis, what that will form? Carboxylic acid, right? Hydrolysis form D, which is on dehydration form E. So dehydration, I'm taking any reagent or heat, which will produce carbon monoxide, and E on reaction with NaOH, once again that will form HCOONe. Under high pressure, it forms a sodium salt of D. D is our formic acid. It is forming sodium salt of D, that is E. Okay. So if the option matches with sodium formate, that is your answer. Then moving on to again the column type of question. Here we have the reactions match with the product. 1 or 2, column 2 may be matched with the column 1. Let's take the first one, ammonium chloride. Ammonium chloride with sodium nitrate. So what that will give? So first that will form ammonium nitrate. Then they have mentioned heat is there. So which eventually will give H2 with H2O. So A2, Q and R. Then the next one, ammonium chromate, dichromate upon heating. So upon decomposition, that will give you again nitrogen with chromic oxide and water, isn't it? So N2 and water, that is Q. Then only column that is having yes, that is C, yes, and nitrogen is also there. So which will give you Q and R for C, and D, where I am having urea with nitrous acid. Urea with nitrous acid, that will produce carbon dioxide, N2 and H2O, which is a fertilizer. Right? So nitrogen it is releasing. That's why we were using that as a fertilizer. Not anymore, but we were using urea as a fertilizer, which makes D2, N2R, P and Q. Okay, so these are the answers to this question. And moving on, this question is related to phosphorus, different type of phosphorus. The first one is white phosphorus, lead phosphorus and black phosphorus. You can easily match it because these are the properties given over there, right? So white phosphorus, which is insoluble in water. Okay, that is poisonous. Yes, that is poisonous. So all are P4 only, but we have to look into which options are right. So let's look for white phosphorus. White phosphorus is poisonous. Yes, that is true. And it evolves phosphine, PH3, right? So that is also true. Less active, most stable, no. Then comes insoluble in H2O, that is also true. Then comes red phosphorus. Red phosphorus, the properties matches here. It is insoluble in CS2, that is right, U. then that is insoluble in H2O. T, is it poisonous? Not as white phosphorus, and this is less active. Correct? Then black phosphorus. Guys, these are inorganic is the part where you have to know more about the properties and how that is reacting, the simple reactions. Like organic, we can't say this is there. Inorganic part is more about practice and memorizing the properties. Okay? And black phosphorus, that matches with, that is more stable, that's not much reactive. So answer to this question is this. You can take this question and match it with this because I have told you this is more about the reactions, right? From starting from S block elements, P block elements and D and F block elements, mostly the questions asked from the reactions, particularly S and P block element. Okay, reactions and the properties. So you can check this and let me know. I think this is 9th question, 9th or 10th question, let's say. So let me know in the comments which is the right answer to this question. I'm telling you one part of column A can match with the one or more of column 2. Okay, so let me know the answer in the comments. Total number of species which has or have symmetrical electronic distribution of homo and also paramagnetic. Both the things we have to know. So what we have over here, that is N2 plus. So N2 plus will have 13 electrons, isn't it? So which will have 1s2, sigma 1s2, sigma star 1s2, and same for sigma 2s also, sigma 2s star. This is less than 14, so which will have pi 2px, pi 2py, and sigma 2pz. So total of 13 electrons. And what about the symmetrical electronic distribution? Is it paramagnetic? Yes, it is paramagnetic. Is it symmetrical? Yes, it is symmetrical. On the HOMO. HOMO means highest occupied molecular orbital. Okay, occupied thing we have to see. Hope you know about HOMO and LUMO. HOMO means highest occupied molecular orbital. Here that is sigma 2pz. Is it? That is having one electron. LUMO means lowest unoccupied molecular orbital. Okay, let's have for O2 2 minus, which will have 18 electrons in total. Correct? And HOMO of this, that is pi 2px and pi 2py. Both are fully filled, of course. Is it paramagnetic? No, this is diamagnetic. So which is not our concern. Then comes C2. C2 will have 6 plus 6, 12 electrons. Correct? HOMO part, which is pi 2px and pi 2py. Again, these are fully filled. Is it paramagnetic? No, this is diamagnetic. So as of now, 1. Moving on to O2. I'm writing O2 over here. O2, which will have 16 electrons, isn't it? That is paramagnetic. What about HOMO? That is symmetrical also. Because 16 electrons, it will have pi 2px1 and pi 2py1. So this is having both the conditions satisfied. Then comes B2. It's 5 plus 5, 10 electrons in total. Is it paramagnetic? Yes, it is. And HOMO, that is symmetrical, which will have again pi 2px 1 electron, pi 2py 1 electron. In case of oxygen, it was pi star 2px and pi star 2py. In boron, that is the bonding molecular orbital. Then C2 2 minus. So total that will have 6 plus 6 plus 2, 14 electrons. The HOMO part, that is sigma 2pz, 2 electrons, which is fully filled. And this is diamagnetic, so not is our concern. And finally N2 2 minus, 14 plus 2, 16 electrons, which will have paramagnetic. Yes, that is paramagnetic, and that is symmetrical too. So guys, I'm telling you, 14 up to 14 there will be one configuration, you know that very well, and after 14 there will be another configuration. I suggest you to have that signs, not the diagram you are drawing, okay, have it like this thing, like sigma 1 is 2, sigma star 1 is 2, like that, okay. So if you are drawing each and every molecular orbital diagram, then it will take more time. Okay, so what is the answer to this question? 1, 2, 3, 4. So to total 4 is our answer. Then the next question, T imparts violet color with compound U and concentrated sulfuric acid, it is forming red gas. And with NaOH, AgNO3 forming red precipitate, and with ammonia forming X. That red precipitate W with dilute HCl forming Y, that is white precipitate. U with NaOH forms Z. Gives white fumes with HCl, sublimes on heating, identify T2Z. So that is our question. These are the options given. Okay. So from the given options, T imparts violet color. So obviously that should be of potassium. All are potassium. Okay. So any other clue point? Y is white precipitate. Let's check Y. It's mercury chloride. Here the Y is silver chloride. That can be our white precipitate. And here barium carbonate is there. And calcium carbonate. Both are white. Okay. Rather than this, W is red precipitate. Ag2CrO4. Chromic is there, so can be of white precipitate. Sorry, red one. And mercuric iodide, that is not red. And option C is talking about, again, iodide, it is not red. Silver nitride, that is not red. So only option matches with W, that is option B. Let's check the remaining also. Z is the gas from U. Z is N2 in the first option, ammonia, ammonium chloride, and SO2. So option B takes all the possibilities without proceeding through the reaction part. Let's check with the reactions as well. So we took T as potassium dichromate. So potassium dichromate with U, that is ammonium chloride, which is forming chromic chloride. Then again that is with sodium hydroxide and AgNO3 forming a red precipitate. AgNO3 forming a red precipitate, that is Cr2O4. That is our W. Then W with ammonia giving X. This reaction we very well know, that is giving X, that is AgNH3, that is mean complex of AgNH3 twice plus. Okay, then W with HCl forming Y, with HCl forming Y, that is AgCl, white precipitate. Then U with NaOH forms, this is U with NaOH forms a gas, that is ammonia gas, along with that HCl will be released, that is our Z. Okay, so that is what the reaction is. So answer to this question is option B. So you have to think more which options is more suitable. This question is from coordination compounds. How many complexes exhibit geometrical isomerism but not optical isomerism? Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 complexes. Let's take one by one. The first one, which is chromic complex with oxalato. As you can see, which is A3 type, not A3 type, AA3 type, right? So which is in bidentate ligand and which can't exhibit any type of isomerism. The second complex, that is again AA3 type, but here you can see the twist. It can exhibit optical isomerism because it can form a structure like this, no? With metal. So It can exhibit optical isomerism but not geometrical one. We want the geometrical but not optical. So moving on to third one. Cobalt NO2 4 times, NH3 twice. Right. So this is A4B2 type. This can exhibit cis and trans. Cis and trans but not no optical isomerism. It can show. It cannot exhibit any optical isomerism. So which can be our answer. Then the fourth one, that is again AA2 B2 type. So which can exhibit geometrical isomerism, that is cis and trans. The cis one can give D and L, but we don't want that. We don't want any optical isomerism. So that is omitted. Then this one, which is A3B3 type. I think this is fifth one. A3B3 type. So A3B3 type, there is a special isomerism. That is facial and meridional isomerism, isn't it? And this can't exhibit any optical isomerism. So this can be counted. And the next one, the platinum complex, that is A2B2 type, which can show cis and trans, not the optical one. So that can be counted as well. Then nickel cyanide complex, which is a square planar complex, it can't exhibit any isomerism. Then our aqua one, A4B C. So this type of isomerism can exhibit cis and trans, not optical one. So this also can be counted. Then PPH32 Cl2, which is a square planar complex which can exhibit cis and trans. And finally we have rhodium complex that cannot exhibit any type of isomerism, because all four ligands are different. So how many can exhibit geometrical but not optical? This can be counted and this can also be counted. Then 3 can also be counted. This one and this one. So total 5. So 5 is right answer to this question. Okay. Moving on. This is an important question. We have discussed this in DNF block elements also, in Redox also. Right? In some mole concept part as well. MnO4 minus, in alkaline medium how it reacts, acid medium and neutral medium, how it goes. This question can be simple if you know the concept. So they are asking for how many electrons are involved over there. As simple as that. Okay. So in alkaline medium it is forming MnO4 2 minus, right, which is a green solution. And how many electrons it is taking? That is 1 electron is participating over there, right? So alkaline medium, X, that is 1 electron. So let's check out the options. D can be omitted. Then acidic medium. So Y electrons in acidic medium, it is forming a puff color solution. How many electrons are involved over there is, we know that is 5 electrons, right? So answer must be option B. Let's check out for neutral medium as well. In neutral medium it is forming MnO4 minus to Mn4 plus, which is black in color, and it is involving 3 electrons. So option B is the answer to this question. You must know the concept, then only you can do this type of question. Then it is the combined question of coordination complex with electrochemistry. Ma'am, how do we know how much conductance it is having? See, examiner don't want you check the physics part of it. They are just asking you to check the chemistry part of it. Okay, think in that way. So conductance is related to number of ions, right? Is directly proportional to the conductance is directly proportional to number of ions. Correct? So here how many ions are there? And as a basic concept of coordination complex, the ions inside the coordination complex will not dissociate in aqueous solution, right? So apart from that, 1 in the sphere and 3 outside. So total 4. And here 1 in the sphere, 1 outside, total 2. 1 in the sphere, 2 outside, total 3. 1 in the sphere, 4 outside, total 5. So as I told you, conductance is directly proportional to number of ions. So yes, which will have more, that is D. So yes, this is D, and then the highest one is P. The second highest is C. So C, okay, let me write it in this way. This to this, and then this is to P, and then comes 3, that is A. Then finally Q to B or B to Q. Okay, so this is how you have to solve this type of question. Simple question, but you have to know the concept. Here comes. So you can solve this question in a minute. Believe me, you can solve this question in a minute. Only thing you need to know about the ligands and spectrochemical series. I already told you the first digit of the Bohr magneton value will be equal to the number of unpaired electrons. So every time you need not to put the formula and find out what is the root of that value. No. That is totally time waste. So the number of unpaired electrons, which is just equal to the first digit of Bohr magneton value. Okay. So let's see. The first one, FeCN6 4 times, where the Fe is in +2 oxidation state. 2 plus oxidation state, isn't it? And here Fe is in 3 plus oxidation state, and here I'm writing it 2 plus, 3 plus, chromium which is in 3 plus, nickel that is 2 plus, and iron that is again 3 plus oxidation state. If you are counting the number of valence electrons, here you go 3d6, this is 3d5, chromic that is 3d4, not 3d4, 3d3, isn't it? 3d3, and nickel 3d8, iron once again 3d5. Okay, so which is having highest unpaired electrons? Obviously among this, fluoride ligand, that is weak field ligand, so it will not undergo para. So 5 to Q. So this one to here. Remaining what we have, another 5 electrons are there in Fe3 plus of cyanide ligand, that is a strong field ligand, so which can undergo para, and remaining 1 electron will be there. So this goes here, and 3 electrons in chromic, what aqua, that is a neutral ligand, so 3 electrons as such, so which will go here, correct? And nickel aqua complex 3d8, so 3d8 means how many unpaired electrons? 3 unpaired electrons, isn't it? 1 2 3 4 5 6 7 8, 2 unpaired electrons, so which means this 2 here, and what we left with, the first one that can undergo para, 3d6, the remaining I don't have any, which means 0. Okay, clear? So if you are doing it within 1 minute, you can easily solve these type of questions, but which can be asked in your examination also. Okay, so this question once again asked from the bridged coordination complex, that is Fe2CO9. Which of the following is incorrect? Okay, you have to know about this structure, otherwise you can't answer to this type of question. The first option is it contains no Fe-Fe bond. The second one, the 2 type of energetically different synergic bonds are present in it. Synergic bond is kind of a backbone scenario, right? And option 3, that is 3 CO or bridging ligands. Okay, and it follows EAN rule. Okay, so first let me give you this structure. So Fe is connected with Fe, so which is the correct statement? And here I'm having 3 bridging ligand and 3 terminal ligand of each Fe. So this is the structure of Fe2CO9. Okay, let's check it with the options. Two type of energetically different synergic bond. So I told you synergic bond is kind of a back bonding scenario. Particularly in carbonyl complex it happens because of the empty orbital of our metal ions. And metal ions and the we take empty orbitals in the carbonyl ligand and the electrons in the metal ion. So here you can experience one type of synergic bond. This ligand is attached with two metals, and here the ligand is attached with only one metal. So this is another type of synergic bond. Not another type, that is energetically different. So this is also a correct statement. There are 3 bridging ligand, that is also a correct statement. Okay, there is no Fe-Fe bond. So this is an incorrect statement. And the last one, it follows EAN rule. So EAN rule, how many, what is the oxidation state of Fe here? It is a carbonyl complex. So we need not to worry about the oxidation state. So total 26 electrons, right? So 3 electrons in case of terminal. So 2 into 3 ligands plus 1 electrons in case of bridging. I'm considering only one Fe, okay? So 1 into 3, then Fe-Fe bond, that is 1 electron. So 1 into 1. So total 26 plus 6 plus 3 plus 1. So total 36. 36 is an inert electron, inert gas atomic number. So it follows EAN rule, which makes it much more stable. So answer to this question is option A only. Then these type of questions you can easily solve. MnCl4 2 minus, what is the hybridization and whether that is paramagnetic or diamagnetic. So that is what the question is. I'm giving you 10 seconds, or you can pause the video and write the answer in the comment. Once you are done, you can unpause the video and check your answer. So as you can see, MnCl4 2 minus, let's say that is A. So the answer is, that is paramagnetic and sp3 hybridization. Then nickel cyanide complex, that is diamagnetic because of strong field ligand, and that is dsp2 hybridization. So Q and S. Nickel carbonyl complex, that is sp3 hybridization, then carbonyl strong field ligand diamagnetic. Then copper amine complex, that is paramagnetic and dsp2 hybridization. Okay, so the answer is right. Give me a thumbs up in the comments. Okay, great. So then this type of questions can also be asked for matching with the isomerism and as well as whether the complex is high spin or low spin. Okay, so high spin means more the number of unpaired electrons, low spin means the number of unpaired electrons are less, okay, even 0. So you can see the first one, that is AA3 type. So in this type of complex, it can't show any optical activity. Here you can see the another type of question can be asked from coordination complex, which combines the isomerism as well as the unpaired electron part. Okay, so if you know the answer, just put it in the comments. Please solve it, these type of problem also, or whatever the answer you are getting, mention it. I'm giving you the right answer. The another type of isomerism part, which is ionization linkage isomerism, as you can see, which is sodium Na2 Pt SCN2. So SCN is there, so obviously it will have a linkage isomerism, and this is AA2 type. So it can exhibit linkage isomerism, geometrical and optical. So A2, Q, R and S. And B. So talking about B, A2, B4 type, which can exhibit ionization isomerism because outside the coordination sphere I am having an ion. So P as well as R, there is no optical isomerism for this type. Then NO2 glycate and amine complex. In this type you can expect NO2 is there, so linkage will be there. Other than that, geometrical isomerism is also possible. Then D oxalate with hydroxide, AA2 type, where you can see geometrical and as well as optical isomerism. So R, N, yes. Okay. Then select the correct statements about soda ammonia solvay process. The option A is in ammoniation tower, CO2 is limiting agent, and carbonation tower, ammonia is limiting agent. Byproduct of the process is calcium chloride, and calcium carbonate is formed in the carbonation tower, and sodium bicarbonate is formed in the ammoniation tower. So in the ammoniation tower, ammonia is absorbed into the water, right? So let me show you the diagram of how this process happens. So this is the overall process and how the ammonia is recovery happens over there. There will be a setup of 2-3 containers. Let's see the options one by one. As I told you, in ammoniation tower, ammonia is absorbed into the water and CO2 is not introduced over here. Okay, so which can't be our answer. Then in carbonation tower, ammonia is a limiting reagent. So in carbonation tower, CO2 is bubbled through the ammoniated brine. Okay, so here ammonia is in forming a precipitate. It forms the product of sodium bicarbonate. CO2 is our limiting reagent, not the ammonia, right? So which can't be our answer, and the byproduct of the overall process is CaCl2. That is true. So this option is right. And calcium carbonate is formed in the carbonation tower and sodium bicarbonate is formed in the ammoniation tower. So calcium carbonate. So as you can see, sodium bicarbonate is formed in the carbonating tower and calcium carbonate is not formed over there in the main process. So we are getting it in the later recovery. So option D is also wrong. So only option C is our right answer. This question is related with our solutions and colligative properties chapter as well. Okay, see this question. This is a hydrated complex. 1 mole of aqueous solution of which freezing point is 269.28 Kelvin. Assuming 100% ionization of the complex, find the complex. From the given options, we are going to find the complex. How we can find? All of these are having same number of water and chlorine, right? So there is a way to find it out using 1/2 factor, right? So we know the formula delta TF, which is equal to IMKF, right? So normally they have mentioned that is aqueous solution. So the freezing point, that is 0 degrees Celsius, which is nothing but 273 Kelvin. So 273 minus 269.28, which will become 3.72, and I factor we don't know, and 1 mole that is mentioned over there, and Kf value of water is 1.86. So I becomes 3.72 by 1.86. If you are finding out n value also, that will be same. So I am taking 2 as I. So I2 means 2 ionization has been formed, because they already mentioned 100% ionization is happening over there. So end of the complex, there must be only 2 ions formed. So there is a mistake in option, this must be 4. Okay, so here you can see the first option, if I am not mentioning 4 also, that is not matching with the formula given, so which is not correct. And the second option, that is having total 3, 2 outside the sphere, 1 from the sphere. So total 3 ions are there, so which is not our answer. Then option C, that is having 2, so which can be our answer. Then option D, that is having only 1, which is not our answer. So answer to this question is option C. So that's it for today. Mostly I have covered all the concept of inorganic part. Anything else, any other concept need to be discussed means, let me know in the comments. We'll discuss it. Okay. Keep practicing more and more questions. If you have any question also, you can upload it in our website. We'll answer it within 4 hours. Thank you guys.